So here's another mechanism. This is cleaving an ether. So breaking the ether into two component parts. The alcohol and an alkyl halide can occasionally be useful. And this can be done with the halogen acids like HCl and HBr. In fact, it is basically the reverse of the base catalyzed ether formation. So we use the strong base to form an ether out of these two parts. We can use a strong acid to break it back into those two parts. So again, ethers react a lot like alcohols. They don't have a good leaving group. They're not a particularly strong nucleophile, right? But you can do reactions with acids with them. So you can protonate this oxygen atom with a strong acid like HBr. All right, so our first step, just like with alcohols, is a proton transfer. And that gives us just the protonated version of this diethyl ether. And Br minus. Right? So in this case then, now I've got two sides here, but a good leaving group kind of split between them in the middle. So I can do an SN2 reaction with a nucleophile, breaking this off as a neutral leaving group. Right? So in this case, this makes sense to do an SN2 because that is just a primary carbon there. On a secondary or tertiary carbon on a different ether structure, it would break off as an SN1, where the bond would break first before the nucleophile ended. So in this case, you can do SN2, but this also works as an SN1 reaction. Just depends on the carbon group you've got right there. Right, but now I've neatly made my alcohol, this left-hand side here, and my two carbons, bromine, alkyl halide, on the other side. Right, so splitting the ether back into an alcohol and an alkyl halide.